analysts who are familiar with SQL, but they may not have a clear understanding how machine learning works. And so machine learning appears like a command in a query. And in order for that to work, you need to make a lot of assumptions, and the end user may not always be familiar with this. So here's an example from one of our hackathons in the company. There was a team that wanted to analyze text and build a text classifier. And they picked a machine learning algorithm that was available in BigQuery. And this by default encoded everything that is text through one-hot encoding. And then you can imagine it didn't work at all. And the team was just not familiar with how that works. Another report from the coalface is a team that built a classifier for propensity of customers to call us. And they built a naive base classifier using an R package. And this particular R package can use numerical and categorical features, but they couldn't deploy it because the environment they were deploying to would not allow them to load up R libraries. It was a Spark environment, and they had to use Spark ML. So they started to remodel using Spark ML. The library that they had available could only use categorical features encoded as numbers, which they interpreted any numbers are fine. And so that meant they could keep using their numerical features, which they had in their original model. So what they did is they converted categorical features into numbers and kept the numerical features the way they were. And luckily, they had some negative numbers in their feature values. And this is why the software just refused to work with it. Otherwise, it would have produced something that then it seems to work, but wouldn't have worked at all. And so the kind of documentation they had to work with is then the documentation in R, which tells you something about how to use it and what the data this function can use should look like. And so here it says a data frame of categorical or numeric variables. And if you look in the Spark ML documentation, this is much more sparse in terms of what's available to the user. And so you see here that data consists of labeled points, and it looks like it's a numerical vector. But in effect, these are basically encoded categorical values encoded by one-hot encoding, which is not clear from the documentation at all. The other problem that we're seeing with machine learning is the fact that people are not familiar how the data goes in and is being processed. If you're familiar with using software, then you know that software checks its inputs. Right? So here's a very trivial example, a field where you have to put an email in, and when you use this on the web, then you're used to getting an error message if you mistype your email in a way that it is no longer a valid email format. And obviously here, this is an attempt of SQL injection. So you're picking up input errors that users are making in order to guard against security attacks, any sort of kind of misuse of the software, but also kind of random errors that users are making when they type in information. The problem is that machine learning doesn't do that at all. So here are pictures you may have seen. This is essentially adversarial images, but these are random images crafted so that they elicit a certain response from a machine learning model that has learned to recognize images. And you can see that it produces a response to whatever you chuck into this model. It never comes back and says, I have no idea what that is, or that's not something that I've learned about, or this doesn't fit the data that you have trained me with. The machine learning model doesn't have this capability. And so we will see the creation of models that are not basically checked in the software engineering sense against inputting wrong data. And this becomes more and more a problem the less familiar people are with these kind of concepts, and the more they are being encouraged to use kind of tools that build machine learning models. In BP, we are having this concept of AI factory or a model factory. And the idea is that we have thought about what are these kind of stages that people go through when they build models. And we realized that you need to do testing at every stage. And so the idea is to learn from software engineering, where developers are used to describe test scenarios before they even write code. And these tests are executed automatically every time your code is compiled and before it can be deployed. And we need sort of this sort of attitude in data science as well, not just for citizen data scientists or for democratization of data science, also for ourselves. We need this as a capability. And so this should start as early as the data repository. So the data that sits in the repository should already have been tested. And this is essentially data governance, data quality. Don't let bad data get into your repositories. Then you make life much easier for data scientists or citizen data scientists, who then won't have to struggle with certain types of data issues. But it's important to start there. And this is not really supported. Although in old school database systems, you have something like triggers, which you can specify when you design tables and relationships, and that basically prevents you from adding wrong data into your table. Not a feature that is really used anymore. Then when you go into data wrangling and generating features, when you actually start working with data, there's very little support for testing, and this is what we really need. The first support for testing comes when we build models. We have automated cross-validation and things like this available. Any algorithm can now do this, but testing of data is not really supported. The next crucial test for that applies to data is then when we apply the model, and this is where I've talked about garbage in, garbage out, right? So we need to test that the data that we're feeding into our models is still the same type of data that we trained it with. And we need support for these things to happen automatically. So it has to become very, very easy, especially for citizen data scientists, to say what they expect the data to be like. That would naturally lead to automated tests that can be carried out in these kind of data pipelines or model pipelines that in the end will spit out a model or an analysis. So when we think about this, then we naturally think about automation, and the obvious automation that we are all seeing these days is AutoML. It is relatively straightforward to automate things like data pipelines, model build and test, deployment, in-life monitoring, decision tests, A/B testing, all of these things. Even reporting can be automated, although I'm missing the capabilities for that. So we really need automated reporting so that people cannot just produce results by analyzing data, but that they automatically produce a report about what they have done. Also the kind of stuff they have done without showing it in the end, because we are still missing a lot of reproducibility and versioning and the documentation of things that have not worked in the whole process, so that people can learn from it when they pick up the flow at some later stage. It is obviously more difficult to automate data wrangling and things like data quality monitoring, because you need domain understanding. You need to know what the data represents that you're working with. And so this is not something that can be fully automated, but it is something where automation can make life much, much easier. And if we make life easier, then certain things start to happen. At the moment, nobody really wants to work in assuring data quality and preparing the ground for analytics, because it's boring, it's hard work, and it's very poorly supported. And this is where we need to invest. And then it becomes hard to automate things like feature crafting, evaluating bias and fairness, because you need even more domain understanding and business understanding for this. And this is kind of where I see the focus for data science in the future, to create good features that will lead to good models. So let's take a step back and look at the kind of personas that we see in large organizations like ours who have to start working with data. And again, we have to be careful that when we look at it from an academic point of view or professional point of view as data scientists, these people have not the same backgrounds, not the same needs, and they're not looking for the kind of tools that we fall in love with because they make our life much easier. Business analysts is one typical persona. They're used to work with spreadsheets and simple charts. They lack understanding of data and data science algorithms and methodology. They can't use SQL or write code. We have data engineers who are already close to data. They are used to SQL and design of data repositories. They have understanding of data quality and governance, can write some code, but they lack understanding of data science algorithms and methodology. But you see a lot of these groups of people thrown into data science work. And then you have software engineers who are used to write, testing, and versioning code. So they come from a kind of a very highly evolved engineering discipline. They understand data structures and they are comfortable with algorithms, but they lack understanding of data repos and data science methodology. So all of these personas have different needs when it comes to help them to get access to data science and work with data and produce reliable results. And this is where I think we need to shift focus. We need to focus on data, testing, and automation, and data comes first. And I also want to, like Ben, point to what Andrew Ng is currently saying. So the kind of data-centric view of AI, make the data the focus. And people need to understand that this is the raw material they're working with. And if this is not of good quality, then nothing they do will work out. And currently we have too much of a focus on fancy tools and algorithms. The idea of you can just press a button and things are magically happening. The kind of work that you have to invest upfront in understanding what you're doing and what you're working with is not really emphasized. So I would suggest that we think about collaborative workflows and not tools. Collaboration is essential. Domain experts need to be able to work together. There needs to be a collaboration with data engineers and data scientists. They need to be able to hand over what they have started when they have figured out that there are interesting results here that could be productionized. So then we want not to start from scratch, but we want to see a handover of a workflow. And that means we have one of the challenges is how do we version and reproduce ad hoc workflows that are created through trial and error. If we look like a great tool like Einblick, which already facilitates collaboration and workflows and supports users, but how do we capture this as a kind of a change over time? So the kind of flows that are being developed through collaboration in tools like this, they change. They're not being designed once and there they are. We not only want to see the final version, we want to see the steps in between. And how can we version complicated things like this? We need to help people to work visually with data. That means they need to view the data in a way they're used to. This is typically in form of a table, but we need to visualize data. When they access data, we immediately need to create reports about data quality, about missing data, about anything that looks weird in data. And we need to visually help them to find these things and fix them or make them aware that the data may not be of the quality that they're thinking. And we should also rethink AutoML. We need to constrain machine learning and make it safe to use. That means not chasing the most accurate model, but the simplest model that people can get their head around, that makes sense to them in the business context, which will also help us address things like bias and fairness and explainability. But this is what I see in terms of what we need to do to help people in businesses to make use of data science more frequently and with better results. Thank you very much.
Thanks, Detlef. All right, any audience members who are live here have any questions for Detlef? All right, I'm going to take a look at the Q&A while I do that. Detlef, do you mind expand? Oh, wow. All right, Paul, you're live. Do you mind expanding on point number 3 under refocus and maybe providing like a concrete example of that where you can make a reasonable trade-off between accuracy and just the business being able to understand or follow what the teams that are supporting them are suggesting they do or incorporate?
You mean find the simplest model, not the most accurate?
Yeah, because I think we find a lot of in our experience that people over-rotate towards the most accurate as opposed to something that's actually actionable and the business will trust.
Yeah, so I mean, one important thing is always to understand if you build a model, how can you deploy it? If you are not already working in a kind of a modern cloud-based environment where you can deploy whatever, then you may have to carefully think, how does it fit in your internal environment and infrastructure? So for example, in the past, we had to build models that would be able to run in an Oracle 8 environment and just use integer arithmetic, because that's where the workflow system was running and making decisions. And there was no way to say, oh, we have a fancy deep learning model here in the cloud that we can deploy, and that's very accurate. The other thing is that simpler models are easier to understand, and people need to understand what they are doing. They need to understand the data, and they need to understand the results. It's not about building black boxes. And if you want to check things later for bias and fairness, and things look weird, you want to be able to look into the model and understand why that is. That is much easier with simpler models. And the use cases that we see in organizations like ours has nothing to do with like classifying images or processing natural language data. This is kind of the far end of the complexity scale that citizen data scientists are rarely coming across. And they need to build decision models and workflows. Should I send an engineer to fix a fault, or can I do something automatically? It's about marketing situations. Should I treat a customer for churn or not? And these kind of decisions may have to be conveyed to a person who then needs to make it real. So if a decision model says this customer is of risk of churning, and this information is displayed to a customer advisor who is in a conversation with a customer, then more context needs to be provided. So there needs to be a why do we think that? And so this is the kind of context that we should keep in mind when we generate models automatically. And we need to somehow make sure that we're not creating something complex on simplistic data. And so when we train our own people, we always tell them, start with the simplest possible model before you try anything more complicated.
Great. I think we'll have time for one more question before we enter our next break. And so from the Q&A, what areas and skill sets would you advise to develop or invest time in to develop for someone who's just starting working as a junior data scientist who wants to have a long run in the space? So, 5 to 10 years off into the future.
Yeah, start with the basics, learn statistics. That's what I would recommend. It's what we're doing is basically advanced statistics. Any kind of machine learning is statistical machine learning. So get to grips with the basics, understand what data is about, and learning basic statistics is the best first start.
That's super helpful. One quick follow on actually on that thread then. So we hear a lot about organizations investing in educating their business folks about statistics and how to interpret them, et cetera. How does BT think about the reverse of that? You hire people with statistical skill sets, data scientists, machine learning engineers, and you need to educate them about the business. Do you have a formal program for that, or what's the approach?
Yeah, we do. I mean, hiring people with like data science skill is very, very difficult. But yeah, of course, people who join the business get skilled up in the business. And we have different forms of doing this. We have a graduate model where people are trained in the business for 2 years and rotate through different departments. And there are different ways of helping people to get to grips with the business. And the kind of data science work is usually done in very close connection with the business teams.
All right, fantastic. We'll give it up for Detlef. We're really much appreciated for joining us today.
Thank you for having me.
All right, folks, we are entering our first break. It's going to be a 20-minute break, and then we'll start back up at 10:25 again.